In this video, we are going to use proportions to solve problems involving shadows, also known as similar triangle problems. So shadows made by two different height objects by the sun when they're nearby will create something called similar triangles, similar right triangles. So here we can see that we have a tree, a taller tree casting a shadow, and we have a shorter person casting a shadow. What we want to think about is how that tree creates a right triangle. So the height of the tree is one leg of the triangle, the shadow is another, and the imaginary line between the tip of the tree and the end of the shadow creates our hypotenuse. Same thing with the person. And under these conditions, these triangles will be similar, which means they have a similar shape. So what that means is that we can use a proportion because the ratio of the length of the two legs will be the same. In this case, the height of the tree to the length of the shadow. I would normally set this up with the height on top just to be consistent. So let's set this up and see how this looks. We have a height of the tree of 15, and we have a shadow length of 21, 15 over 21. For the person, we have 5 foot tall, and we have a 7 foot shadow. Now, let's divide this out. 15 divided by 21. Use your calculators, and you should get 0.714. And if you divide 5 by 7, you should get exactly the same number. Those are equivalent fractions, and they have exactly the same value. That's what happens when you have similar triangles. So the purpose of this discussion is to show you that this is the case and how it can be used to solve for one of the missing dimensions in a problem like this. Usually the height of one of the objects. So before we get to that, one tip: try to estimate your answer based on the picture before you go through the math. It might help you eliminate some ridiculous answers. So let's take a look at this from a practical standpoint. This is a 6.5 foot tall person, and they're making an 8 foot shadow. Their shadow is a little longer than they are tall. So that relationship is going to hold for the building. So we have a building that's making a shadow that's 32 feet. That means that the building is going to be a little bit shorter than 32 feet. And it's okay to make a guess. I might make a guess that this is about 25 feet. That feels about right to me. We're going to need to do the math to get the exact answer, but it's a good idea to make this estimate so that you can eliminate answers that are not close to 25 feet. All right, we'll talk about that as we go through a few examples here. I have 3 sample problems. This is just another kind of picture that you might see that communicates the same thing. We've got a tree casting a shadow. That shadow is 42 feet. We have a person casting a shadow. They are casting a 12 foot long shadow. We know that the tree is 14 feet high, and we are trying to calculate how tall this person is. So let's set up our proportion. Our tree, so once again, we're going to put the height over the shadow, and we will start with the tree here, and we will do our person here. So the tree is 14 high and 42 foot shadow. The person has a 12 foot shadow and an unknown height. So this starts to look like a proportion problem. Let me change my color as we finish this off. We're going to solve this proportion problem just like we have before. So just a refresher on cross multiplication. We're going to multiply those corners. That gives us 42x. We're going to multiply these 2 corners. 14, and 12. That is 168. And then we divide both sides by what x is being multiplied by. In this case, 42. That cancels that 42 out, and it leaves us with x is equal to 4. So that's a pretty short person, but maybe it's a child, and it appears that they are 4 feet tall. And if we had guessed based on 14 feet, we would have said, okay, this is quite a bit smaller than 14 feet. We might have guessed 3 or 4 feet for that answer. So the picture can be extremely helpful in terms of trying to estimate your answer. Let's do that with this problem before we even get started. So I'm going to take a look at this situation and say that our doghouse here is 2.9, almost 3 feet tall. And the shadow is 7.6 feet. The tree is making a shadow that's 14.5 feet. And we are trying to figure out what is the height of this tree. So we would call this unknown x. And if this is 2.9, I might guess that maybe this is going to be a little bit less than twice as tall. So maybe something around 6 feet, though, maybe a little bit less than 6 feet. All right, let's see what kind of answer we get when we set this up. So we'll start with our tree, our unknown height, divided by our shadow length, 14.5. And then we have the height of our doghouse, 2.9, divided by its shadow, 7.6. We cross multiply, change my color. I'm going to multiply the x and the 7.6, and we get 7.6x is equal to 2.9 times 14.5. And let's do that in the calculator right away. I get 42.05. And then we divide both sides by what x is being multiplied by, which is 7.6. That cancels that out, and it leaves us with x is equal to 5.5, a little bit less than 6, just like we predicted. But now we know the exact answer, and we can feel confident because it was close to our estimate. Can't emphasize how important that estimate is. Example 3. A building makes a shadow that is 25 feet long. The person is 6.5 feet long, 6.5 feet long, and makes a 9-foot long shadow. How tall is the building? So what's different about this problem? Well, our drawing is not labeled. Sometimes you might even get a problem like this without a drawing, and you kind of have to make a sketch. So it might be helpful to make one. So let's label this. Our building makes a shadow that is 25 feet long. So that's this dimension here. Our person is 6.5 feet tall, and they make a 9-foot long shadow. So all of the information is there. It may or may not be helpful for you to write this out, but I just wanted to show you what was different about this problem. Now we can set up our proportion. Our unknown is the height of the building. We're going to divide that, as we have before, by the shadow. On the other side, the height of the person divided by the length of their shadow. Okay, so changing up colors, let's cross multiply. 9 times x, 25 times 6.5, which is 162.5 out of the calculator. And then last step, we are going to divide both sides by 9. Hopefully this is a good refresher on cross multiplying to solve for the missing variable. And we are left with our answer of x equals 18.5. 18.1. And you might answer that 18.1 if you were asked to round to the nearest 10th. We don't have any rounding information here, so you'd be looking for an answer like 18.1, or maybe just 18 would be close enough. All right, that's all I have on shadow problems and similar triangles. Now it's time for some practice on your own.